Hello, everyone. My name is Terry Robinson, and I'm the Executive Editor at SE Media. Welcome to our webcast, Exposed and at Risk, Why Your Approach to Web App Security is Insufficient, sponsored by ThreadX. While web and legacy apps, APIs, and microservices are now common and essential components of any digital business, their ever-increasing complexity also creates vast attack surfaces and prime targets for malicious threats. In fact, according to a recent survey conducted by Ponemon, 80% of organizations stated their web apps were compromised sometimes or frequently. This figure is shockingly high, considering 73% of those organizations were using a web application firewall. So where's the disconnect? Today's speakers will discuss the power of combining proven web application security approaches and modern web application firewall technologies to address the rapidly evolving security needs of hybrid cloud environments. Our speakers today are Michael Suby, Vice President of Research at Stratecast, Sullivan, and Bret Settle, CEO and founder of ThreadX. Bret has served in multiple executive roles for Corporate Express, Staples, and BMC Software, and has extensive knowledge of the software development and security products industries. He's been responsible for enterprise security in multiple roles and has been an innovator throughout his career and has a proven track record of building and developing high-performing organizations. He founded ThreadX out of the deep frustration with the maintenance burden and inefficiency of legacy security solutions and is committed to disrupting the web applications firewall market. Michael is also Program Director for Frost & Sullivan's Information and Network Security Research Program. As an analyst, he contributes to the research themes of Stratecast Business Communication Services Analysis Program with a concentration in secure networking. His secure networking analysis is centered on the technologies, products, and services designed to improve the security of enterprise networks, their business and consumer-facing applications, and sensitive data at rest, in use, and in motion. As you can tell, they are well-versed in this industry, and I'd like to welcome them here today. Hi, Michael and Bret.
Hello, thank you. Well, let me take us forward. Looking forward to today's webinar. So the title of my few slides, right tool but wrong model. This is something that we've actually written about. And are your defenses against web application attacks falling further behind? The first question I think to start with is, why apps? Why web applications? Why web applications? Well, to use the sometimes overused phrase, that's where the money is. Whether we're thinking about ourselves as consumers or in our business personas, web applications increasingly is how we get things done for a variety of reasons. Also for a variety of reasons, there's ample reasons to protect these web applications. And here's just some information from the Ponemon Institute on a recent survey that they did on why to secure web cloud applications. And the respondents could provide a couple of their top responses. And data protection, revenue loss, compliance hit the top three, but there's other reasons as well, as you can see. So what are organizations doing to protect their applications or web applications? Well, for many, 73% of them, they're using web application firewalls. The problem, as previously mentioned at the intro, is that despite using these web application firewalls, and I might say legacy web application firewalls, there is a fair amount of compromises that have occurred. 26% of the survey respondents said that their web applications are compromised frequently, and then another 54% said at least sometimes. So again, you're looking at 80%, 4 out of 5, are saying that their web applications are being compromised. So what I want to do next is go into why is this happening with such great frequency? Well, there are several reasons. I think the most, or what I view as one of the most important, is it's a broadening attack surface. We already talked about there's just an increasing number of web applications, but what's also driving it is the compute environments continue to evolve and expand. Within Frost and Sullivan, we conduct annual surveys on decision makers of cloud computing. And why are they moving to cloud? Well, for several good reasons. One, they view it as essential for them to remain competitive within the industries that they reside. But also, and why, how does this help you to be competitive? Well, over 2/3 indicated that it helps us deliver services and applications faster. But just because you've moved to the cloud, and we found this to be the case, it isn't the exclusive environment where organizations are putting their compute environment. As you can see in this table, they use a variety of environments, whether it's public cloud, hosted private cloud, on-premise physical servers, SaaS, bare metal, and so on. There's a range of computing environments that are using. Now, specifically as it applies to web hosting, web applications, it's generally a split or hybrid environment, or 1/3 are saying it's split or hybrid. And what we generally find is for many organizations, they'll put the front end of their web application in a public cloud environment, and the database and other functionality will reside, say, in the private data center. So some types of that split. Of course, not always, but frequently. With moving to cloud, which has always been the case, I would say, concerns on security are being mitigated a bit over time as cloud has become more popular and adopted. But nevertheless, organizations are still concerned about their cloud usage. 65% are concerned about unauthorized access, and over half meeting compliance requirements. I will add, we asked similar questions of customers in terms of their confidence in security for their private data centers, and quite frankly, we get similar type of responses. They're concerned about unauthorized access and meeting compliance requirements. So in many ways, the cloud is just a reflection of other environments and having similar types of security concerns. Another factor that's adding to the attack exposure and attack frequency is changes to web applications. They generally add to vulnerabilities. And from TrustWave, which has done, an organization that's done a tremendous amount of pen testing of web applications across their customer base, they couldn't find a single web application that didn't have a vulnerability. And in fact, what they found, the median number of vulnerabilities for a web application was 11. And I might add that some of those vulnerabilities may not just be, and could be within their confine. They're looking at software vulnerabilities. One also has to consider various types of logic vulnerabilities. Things that could be used by an attacker to use resources in an unexpected manner. What I think is also important, or what is definitely important to look at, is attackers are not restricting themselves to the front door we get into. Let's move on from there. And so the lateral movement, which is very well known, it is part of the attacker's playbook. They look for a weak link to exploit. They move laterally till they get to their prized target, and they can do that with somewhat ease. And I would recommend, as I listed at the bottom of this slide, there's a interesting blog on this weakest link concept that I'd recommend you take a look at. Another aspect that adds to the vulnerability and the frequency of attacks is that scanning for vulnerabilities is not being done with any great regularity. Again, borrowing from Ponemon Institute's research, they found that only 45% of web applications on average are being tested for vulnerabilities. And then when you think about, for many applications, there's almost continuous changes to them, evolution. Again, these applications are being used for very competitive purposes. 15% are only tested every time there's a code change. So quite a gap between of not being tested for vulnerability and the frequency of being tested not being great. There's the other element of, well, even once a vulnerability or vulnerabilities are detected, they may not necessarily be instantaneously repaired or remedied. And in fact, as you can see in this slide, 46% of the survey respondents said it takes us multiple days just to fix one compromised web application. And it's not unfrequent, 20% or 1/5 said it could take up to weeks. Now the attackers, well, they're not single-minded folks. They will use multiple methods to attack web applications. And here's some information again on what is most common on the left-hand side. What may seem not as common under that column of common is the DDoS amplification attacks. DDoS is another area where we conduct research in, and the number of attacks, the variety of attacks, and the size of the attacks just continue to advance. An amplification attacks where a small packet is being sent to elicit a larger packet response has been growing and becoming more prevalent as a attack method. And again, it's going after logic of the web application, not necessarily a software flaw, but logic to make this exploit happen well. And then, of course, there's zero-day attacks as well. My main point here is there isn't just one attack method who are responsible for protecting web applications need to concentrate on. You need to concentrate on all of them, which obviously that's a significant duty. Another element is attacker motives are not limited to valuable data. While certainly that is a prominent area of purpose in attackers, it's not the only. What Verizon noted in its latest data breach report, which is something we've also been following for a number of years, is there's this element of illicit repurposing of compute and storage resources. And what Verizon found, it's used to send spam, participate in DDoS attacks or phishing campaigns, and store and deploy malicious code. And they found that in their research that they found 23,000 instances of it. And I'm sure many of you in your various engagements with customers and other parties in the cyber industry field, you're hearing similar type of incidents of this nature. And one I just would like to share is where we're finding this is going on is in support of crypto mining. Go in, steal resources from the victim and to use it for crypto mining, which this gets to be rather concerning if, let's say, your web application is hosted in a cloud environment and you've established rules to do automatic scaling. You could be automatically scaling for somebody else's purposes and costing you serious money. As pertaining to the cost of web application attacks, kind of eye-opening number here. In 2017, Ponemon has been studying this for a while now. They pegged it at $3.7 million. That compares to $3.1 million in 2015. A big change and certainly not a trivial number by itself. When you look further down into what are the various components of this cost, reactionary costs of post-breach, internal IT and security reactions represent nearly 50% of these costs. So it's our defenses didn't work, and now we're having to react. That's a big price tag. And so it leads to my question, logical question, shouldn't more attention be spent on prevention to lessen these reactionary costs? Which leads to my next slide saying, what's necessary is that legacy WAFs are due for a remodel, an upgrade. We've been studying the web application firewall market for several years, and in 2017, we determined the market demand for web application firewalls was $700 million. And we project it's going to continue to grow, again, for many of the reasons that business reasons that I talked about earlier. But throughout our research, as we've done in web application firewalls, there's always an element that's straining market demand. And it's concerns about complexity, the frequency of false positives, and of course, the fact that recurring compromises still are happening. So the question then becomes, well, what should this WAF upgrade or this new WAF model, what should it entail? What are some of its attributes? And so as we've conducted our research in this area, I'm going to just narrow it down to 4 that as you go about your effort of looking for that WAF upgrade, what should you consider? Environmentally, being environment agnostic. Again, back to the slide talking about the hybrid approach to compute environments. Not only are circumstances that your web applications could be in multiple environments right now, it's going to continue to be the case, and it's going to continue to change. And so you need a WAF solution that can cover all those potential environments and dynamically adjust as those environments change. You also want to have what I'll call cloud consumability. We are consumers of technology, and the trend is increasingly towards cloud-type model of consuming, purchasing, provisioning, and scaling capabilities. Only pay for what we need. So again, cloud consumability attributes are important. Dynamic defense. This is a term we recently used as we were looking at various things, or various cybersecurity technologies, And what we were noting is that the days of signature-based or more or less signature or pattern-based approaches, while valuable in terms of taking away some of the broad attack methods, is incomplete. In the case of web applications, they're evolving so quickly, but in terms of what they do, but so are the attackers. And so what's necessary is this dynamic defense where there's an understanding of change and be able to adapt to that change, and with that, recognize when there's abnormal and potentially threatening activities going on, and to get a sense of that early on within the kill chain and gather increasingly pieces of information to support decisions as to what is happening, how severe is it, how fast is it going, where is it going, and then from that making good or confident decisions as to how to intervene before real damage happens. And of course, everybody's concerned about operational costs. And so as you look at this next WAF upgrade for yourself, look for something that addresses the operational aspect of the web application firewall. As Brett will talk to you later on, there's a lot of elements to consider about how to be operationally lightweight. So let me just end my little bit here and say, web applications and attacks are increasing in number and intensity. They're moving in parallel. No reason to expect that that's going to change. This trajectory is going to continue. Traditional or legacy WAFs, while valuable, are missing the mark. They're lacking dynamic defense capabilities. A new WAF model, again, with dynamic defense capabilities and epitomized by what we see ThreadX is doing, is needing to be considered, and fortunately is available now. So with that, I would like to pass it off to Bret.
Well, thanks, Mike. Definitely appreciate that, and can certainly empathize with a lot of what you just discussed there. By way of background, we founded ThreadX primarily out of some frustrations we had with kind of the best-of-breed solutions in the market. And we're talking about web application firewalls, but also experiences with next-gen firewalls, the SIM solutions. And the reality really was that most of them, as Michael mentioned, they generated a lot of false positives. And in addition to that, we found ourselves often doing a lot of manual analysis, primarily because static signatures and static rules, they're kind of binary. They look at really a single transaction, by and large, and then they make a blocking decision or they make a alert decision based on matching the patterns. And so as we tried to operate under that rule set, we found ourselves constantly trying to tune the applications using those static rules and signatures, but we're often limited in making compromises in terms of maybe whitelisting certain activities, but therefore knowing we may be creating backdoors to our applications, or being overly cautious because the last thing we wanted to do was cause a false positive, so knowing that we were running kind of under-optimized from a defense procedure. The second piece for me was, at BMC we spent a lot of money on a lot of different best-of-breed programs, and it required us to give, at least quarterly updates at the board level in terms of how well were those investments paying off, how well were they performing, and more importantly, what were we seeing in terms of our overall risk posture and in terms of trends that we were looking at. And to be honest, we weren't getting enough information out of the tool sets because they were simply reporting things like the total number of SQL injections or cross-site scripts, but not giving us a lot of real, true threat intelligence. And at the end of the day, we just found ourselves saying we need a smarter solution, and there certainly are better technologies being deployed in other areas outside of security, using things like behavioral analytics and machine learning, but also taking more comprehensive views of the threats and of the attacks themselves, and we decided to form ThreadX. We founded the company in late 2014. We spent about a year kind of in stealth mode working with some of our larger friendly customers, really hardening the product and getting it ready for prime time, and then really approached the market in 2016, 2017 as we started rolling out. I won't spend a lot of time because I think Michael hit a lot of this stuff, but the reality is, it's a very complex situation out there, and Layer 7 in and of itself is very complex. You have a multitude of different development tools that are being deployed. You have the hybrid cloud environments where you're trying to deploy across multiple environments, sometimes separating databases from applications, and just the sheer complexity, of all those development technologies compounded by the amount of change that goes on. In layers 3 and 4, when you're talking about network and infrastructure, there is change, but it certainly doesn't have the same frequency that it has in an application environment. And so keeping up with all the changes that are coming from that perspective, as well as the changes that are coming from the outside world, it's just very difficult to utilize legacy tool sets like that to keep up with the changes and also to scale with all of the various technical complexities. And so, what's resulted really is what I would call firewall fatigue. So you've got, your crown jewels applications that that you have to protect, but the complexity is so high and the number of technologies to protect is so high that you find yourself kind of circling the wagons, and most companies then really only deploy across 10 to 15% of applications. And granted, some deploy more, some deploy less, but with the shortage of technical talent out there and just the overall cost and burden, 10 to 15% is a pretty common statistic that we run into. But we also know, as Michael commented, the hackers they're pretty good at what they do, and they're pretty good at understanding that the easiest path for them is really to go to those tier 2 applications, to look for applications that are either unprotected or in many cases applications that just don't have the same level of scrutiny. They may be several versions behind on their patches, or they may just have a tier 2 development team or a tier 3 development team, who takes more shortcuts, and their ability to monitor and kind of control that situation is very difficult. And so the net is you've got a situation in the marketplace right now where a lot of companies are using a WAF, but they're only protecting and really being efficient across a small percentage of their applications, and yet the hacker community is really focused on those edge applications where they can do reconnaissance, they can identify credentials, and they can identify other information that allows them to continue to dig deeper into the customer's environment. So when we talk about really what we're seeing from a market need perspective, we're looking at, as Mike mentioned, it's deployment and scalability. It's the ability to cover across a complex environment, multiple cloud, on-prem applications. It really shouldn't matter. You should be able to use a single solution that can be easily deployed across those environments. In addition to that, what we're seeing is, a lot of our customers are saying, I need not just a bunch of point solutions, but I'm really looking for an easy, low-cost, low-burden solution that gives me the protection I need from a WAF perspective, but it also gives me some of the content management, content distribution, the load balancing, and the DDoS protection. From a visibility and accuracy perspective, obviously, what you really want to have is visibility in real time, if at all possible, and you want to be able to see attacks as they're being performed across your entire application landscape. False positives and just general disruption of the business, obviously, are things that will kill a security mandate really faster than almost anything that's out there. But you still need the visibility to all of the attack traffic in order to understand, what's being targeted and where is your risk level at. And then finally, operational overhead. Just the fact that with the shortage of resources and the cost that it takes in today's market, you're really looking for something that is effective but affordable and can be easily deployed and can also be deployed as you continue to change your overall operating environment. In terms of, kind of describing the approaches or the differences between legacy WAFs, and I think we've touched on all this, I'll go very quickly, but when we think about the way legacy firewall solutions, they've been traditionally really driven primarily by static rules and signatures. They're obviously evolving. There are advanced baselining capabilities for applications, and there's lots of additional capabilities being added each day, but at the end of the day, the model itself is really not as effective. You need a solution that was purpose-built that isn't focusing on a single transaction, but it's really looking at the attack as a whole. And by that, we mean monitoring user behaviors and then identifying for users, what are all of the steps that it looks like these users are taking that are abnormal, and can we identify the patterns, and can we identify their progress through the kill chain? And to do that, you really need to have a full context view. You need to be able to look at all of their interactions, correlated in real time, and preferably look at those interactions as they're correlated across all of your applications and potentially with additional threat intelligence of any activities or behaviors that you're seeing across multiple customers. On the correlation side, obviously one of the downfalls of the legacy firewall solutions is they kick out a lot of noise. So you're getting tens of thousands, if not hundreds of thousands of events per day. Typically, it requires someone or an additional tool set to be able to go out and start to pull that data together, perform the correlation back to where you think that traffic is coming from, and then do the analysis to try to understand what you think they're targeting and where you think they're going next. Obviously, at ThreadX, we've leveraged a lot of the modern technologies around behavioral analytics, around machine learning, and just around advanced correlation and analytics to do this stuff in real time so that we can quickly monitor the behaviors and predict where they're going next. We've talked about operational overhead. Obviously, to make those tool sets effectively, it's going to take smart resources, trained resources, and resources that have the time to invest in the analysis and then in the tuning itself. As Michael said, you really need a tool that can change with the applications as they change and can change with the attack vectors in a dynamic fashion. How do you, identify the patterns? How do you start to monitor for those patterns? And then how do you evolve as they change? The other kind of key thing that we look at is, especially with some of the, and even the Magic Quadrant type of vendors that are out there, in the WAF space, the biggest problem with them is, it takes a while before you're really comfortable with what you're seeing. You're going to typically take 2 to 4 weeks to baseline your applications. You're going to monitor the results. You're going to tune the results. You're going to get it to a point, usually after weeks, where you're comfortable enough moving into a blocking status. And then unfortunately, about the time that you get comfortable with it, often that's when the network changes, that's when the infrastructure changes, or that's when you have a new code release. And then you start some of that process all over again, trying to keep up with those changes. So again, what's needed is, a tool set that's able to rapidly monitor the changes in the environment and dynamically adjust the rule sets or create new rule sets to make sure that you have the adequate protection level. And then finally, upgrades and maintenance. One of the key things about a SaaS solution like ThreadX or like some of the other competitors out there is it's highly scalable, it's cloud-based, but it's also being managed so that you're not always responsible for updating the sensors, updating the platform, updating the appliances on an ongoing basis. So when we jump back to kind of ThreadX and really what we do, it's a SaaS-based web application firewall, which means that we have basically sensors that can be deployed in any environment, either routed through our network or they can be dropped into an Amazon, an Azure, on-premise, or virtually any third-party environment. Then we have a cloud-based analytics toolset that is then interacting with those sensors to constantly look at the patterns and the behaviors that we're seeing, not just across that customer and that customer's applications, across all customers. It was purpose-built for the hybrid cloud. That was one of our starting tenets. It's all container-based, which gives us the flexibility to support not just applications, but APIs, as well as microservices. And if you look at what we provide as a whole, it's not just a web application firewall. To compete in this environment, we need to have advanced botnet detection capabilities. We need to be able to provide DDoS protection. We can certainly exist with other CDNs, but at the same time, we can also offer our own content delivery, edge caching, and load balancing. And then something that we were brought into, and when we go through demos, this really starts to come out for our customers, but we offer this as a 24/7 managed service. And the reason we do that is as part of our attack-centric or kill chain approach, we're able to identify risk for each entity and increase the risk as we see more and more either threat behavior or as they progress through the kill chain. But in doing that analysis and correlation on the fly, we're also able to identify very quickly what's being targeted in our customers' applications. And so part of the solution that we offer is really the applications that are being targeted, the URIs that are being targeted, and the techniques that are being used. And we do that because, as Michael said, sometimes our customers are not able to do the vulnerability assessments and kind of keep up with new vulnerabilities that are being introduced, either from the outside world or from their developers. But in addition to that, a lot of what we find is that things are being targeted that don't show up on a vulnerability scanner. They're actually either shortcuts that developers have taken or just plugins that have been installed or other components where the scanners that are out there today have a hard time keeping up with every possibility that's out there. And by us focusing on the attack and then focusing on what parts of the application the attackers are targeting, it gives us a very quick ability to identify for our customers key vulnerabilities and how to address those vulnerabilities. And it's a major component of what our SOC does from a proactive stance. In terms of architecture, and this is really kind of how we feel like we differentiate ourselves most in the market, we can be installed in multiple fashions, as I mentioned before. You can flow traffic through our network, where we will cleanse the traffic and then send clean traffic back to you, or you can actually take the sensors themselves and they can be deployed in your application environment, either as a Docker container or as various plugins that we would provide. But the containers themselves are self-sufficient in that they are doing the DDoS protection with the sentries themselves and then providing what we provide is either on-demand or an always-on style of DDoS. We have a key component that we call active deception. So what active deception is similar to honeypots, but what we found when we were doing deception technologies with honeypots were Number one, the bad guys can typically identify a honeypot from a real application, primarily because of the traffic that's flowing through the honeypot, as well as just the normal integrations that would be required for a real application, and then ultimately how that honeypot reacts. What we found to be much more effective was for us to take customer applications and overlay false URIs, headers, and false responses from the applications in order for us to basically interact with those potentially malicious entities that are out there, but do it in a way where it's all part of what they would perceive as a real application. In addition, we use injection both in active deception but also in profiling, where we will inject JavaScript and or cookies, as well as similar to what a lot of marketing sensors will do. We'll pull back key user agent information, browser information, as well as other parameters such as fonts that have been installed, language codes that are installed, potentially screen size, and other attributes. This is all an attempt for us to detect who's on the other end of the line. It's great for botnet detection, and it's very similar to the techniques that some of the major providers are using out there for botnet. But more importantly, it's excellent at doing IP or user fingerprinting. And the key to what we're trying to do there is the more advanced attacks that are taking place in the market, often they'll be using multiple IPs. And it's important for us, because we're looking at the attack as a whole, to be able to correlate attack information across multiple IPs so that we have the full picture of the overall risk of that particular entity. And then finally, we've got our dynamic application profiling, which leverages our machine learning as well as components of behavioral analysis. Again, in order for us to be able to not take weeks or months to actually baseline an application, we want to very quickly profile the application, profile normal inputs, profile normal outputs, but also take a look at what are the typical error responses and how does that application react to non-typical inputs and outputs. And as we model that behavior, it very quickly allows us to downrate certain things that would normally give off false positives, but not ignore them completely. And that's a key part for us, is we don't want to whitelist things. What we want to do is use that information so that we can understand how to adjust the risk for a particular attacker. All this information then is passed through our decision engine, which again does the correlation, does the analysis, and builds the dynamic rules on how to respond to certain types of attacks. And it's driven off of some key information around either known threat entities, and again, this is much more than a blacklist. This is actually key information about their user agent information, all the way down to the parameters that I described before. But it's also, where do they rank relative to a risk? They may not be something that needs to be blacklisted yet, but it's certainly an entity that we're watching and we're monitoring, because we may have picked them up not just for this application or for this customer, but we may be picking them up across multiple applications and customers. And then more importantly, rather than static signatures, we really focus on what are the behaviors. So we focus on what types of behaviors and what types of abnormalities that when we see these, we know these are typically part of an attack, and therefore they all have a contribution then to the overall risk score. And finally, within the actual container itself, it has its own advanced firewall capabilities. So obviously we can block and unblock entities. We manage blacklist and whitelist within this component. We use a term that we call tar pitting. It's a form of rate limiting. But what this is if we suspect either a botnet or we suspect a suspicious actor on the other end, we may choose to slow down the responses to that particular entity for a period just to see how they react and what they do next, and whether they're actually instrumenting some kind of automation or whether they're actually a real user who's interacting with the application in a way. The other thing that we do is called interrogation. So again, if we know that someone is potentially suspicious, we may choose to be more aggressive with our active deception and our malicious profiling. Long story short, though, is this sensor or this container can be deployed anywhere. We backhaul data then to a cloud-based threat analytics platform, and this is where we do cross-customer correlation. There's shared threat analytics where we can identify what's going on for one customer or one set of applications and use that information to identify if we have a bigger problem or something that needs to be shared with the rest of the containers across our network. In addition, we have more big data kind of security analytics that we apply, and then for those cases, our SOC is continually kind of analyzing data and trends and patterns that we're seeing across customers so that we can use that information, potentially create new behavioral signatures that we want to be looking for, and then deploy those across all containers. Lastly then, we have a threat response platform or a customer interface. And really what this is all the information that we've collected, correlated, and analyzed is now made available so that our customers can see the list of all the suspicious entities. They can see what risk we have and which ones have been blocked. And then for each entity, they're able to really drill into that information, see all of the activity, all of the interactions with one application or multiple applications, and they're able to see what's really driving the overall risk and potentially what drove the block. It creates a very high confidence level for our customers because there aren't a lot of questions about what got blocked or why did it get blocked. There's a very clear set of log information around the various interactions. And then above and beyond the actual consumer interface or the dashboards that we provide, we have the APIs and clients so that our larger customers and our partners are able to utilize those capabilities and load in blocks. So, a quick sample of just a handful of customers. Not all customers like us to announce the type of security they're using, but certainly these customers are fairly comfortable with us talking about them as some of our prime accounts. And then I'll just jump through, very quickly a couple of the customer stories out there. So with BMC, we obviously, utilized them. Their primary use case was they were migrating. They were already a fairly heavy adopter of the cloud, but they were migrating to a multi-cloud initiative whereby they could deploy microservices and applications across multiple cloud providers, infrastructure providers, and have the flexibility to be able to deploy and move based on economic reasons, performance reasons, or scalability reasons. They needed a solution that could be easily deployed across all of their application technologies in these multiple environments, but give them a holistic picture of their overall risk across their applications. Again, very proud of the deployment that we were able to do there to both provide the protection that they needed, but also give them a very low-cost alternative and much greater visibility to what was going on. Global Healthcare Exchange, again, another customer that was heavily invested in what I would call one of the best-of-breed or Magic Quadrant vendors, but the issues that they were running into were, a lot of what we've described today. Lots of false positives, lots of cycles of very expensive resources trying to keep up with the attack vectors that they were seeing and all of the challenges that they were having with static signatures and static rules. They also had a kind of global implementation where they had technologies and development teams spanning around the globe, and they needed a solution that could be easily deployed in multiple environments. Again, for these guys, great case study for us, great reference account, guys that we're very proud to have honest customers. Both of these customers are very instrumental in allowing us to really continue to harden the application because their requirements were fairly robust. So I'll wrap it up with that. There's certainly more that we could get into, but I mean, ThreadX, big kind of key points and takeaways that we're looking for is that we've migrated from those static signatures and rules and really deployed what we call a kill chain-based or attack-centric threat detection and neutralization. We're focused on identifying things in real time so that you're not, waiting to discover them. We're trying to make it very easy to deploy for our customers, fairly white glove from both deployment as well as support from our SOC, and still give them the visibility beyond just the basic metrics that they're seeing, but really visibility into the overall risk and the trends that we're seeing across both their applications as well as our global population. Obviously, a big driver for us is how do we reduce the operational burden and how do we actually help our customers refocus their scarce resources beyond just tuning firewalls, but on to really addressing the higher level priorities. And how do we do this in something that's very easy to deploy and gives very fast time to value in terms of even during the POC, you can deploy on an application and you can start seeing results immediately. So, and with that, I think I'm done, and I'd love to open it up for questions.
Okay, great. Yes, thank you, Michael and Bret. We are going to have some time here for questions from the audience. Okay, let's start with this one. We already have a web application firewall, and it is embedded in our security operations. Can ThreadX coexist with what we already have, and is there a best practice for this coexistence?
Well, I mean, I guess there's a couple different answers to that. The first answer would be back to most folks that do have a web application firewall, they have only deployed it across a percentage of their applications. Sometimes that's due to an inability to configure properly or an inability to deploy in a particular cloud environment or technology environment. In those cases, we're very comfortable coming in and providing protection across an additional set of applications. As far as coexisting, we certainly can coexist with other CDNs, and we can certainly coexist with other security platforms. The key really is we are a reverse proxy style of implementation, and so we need to be in line with the traffic. And so the limitations typically would be if you're using another WAF product, you probably don't want multiple inline tool sets at the same time. But in terms of coexisting with other security products, we obviously can provide the web application protection as well as integration to any of the other kind of major either SIEM implementations or other log correlation type of tool sets.
Yeah, from our perspective, Bret, we get this question frequently about the coexistence, and driving it is several reasons, many that you mentioned, but this aspect of organizations just have a lot of tech. They're using a lot of tech. They built the tech that they have over time, and they just need products or new tech that can just slide in easily. And I think to your point, as you were talking about earlier about the return to value or the rapid return to value of your solution, we hear that again is, if we've got to manage how do we integrate, say, new tech with existing tech, we're just delaying again the return on value for the new tech that we bought. So it is very critical that there's not just a coexistence, but a streamlined means to integrate.
Okay. If ThreadX is tagging IP addresses, why can't the bad guys note that tagging and remove it, or just move it onto another IP address?
Well, that's a great question, and again, I think the tagging that we do is really more internally, and it's a threat intelligence component that we've built in-house. So what we're doing is identifying, the fingerprints for the various IPs in order for us to identify if a particular attacker is using multiple IPs to conduct that attack. Now, we will inject JavaScript, but that's really just to pull the information. When we inject cookies, again, that's great, and as is probably indicated by that question, those cookies can be removed. But for everything that we do at ThreadX, there's not really a lot that we do that's purely binary. What we're trying to do is build a picture of an attack, and we're trying to build it from multiple components. It could be third-party intelligence feeds that we're getting. It could be things like how we're tagging these IPs and putting a risk that's associated with them. It could be the intensity of the attack. A particular user that we're seeing on an application is interacting with that application at a much higher rate than the normal user would do. So there's multiple factors that we're taking into account to try to build a clearer picture of how normal or how abnormal is this particular user, and beyond that, what from a kill chain perspective, what do we think they're trying to accomplish? Are they trying to do reconnaissance? Are they scanning? Are they mapping? Does it look like they're kind of going low and slow but still trying to do brute force under the covers? Does it look like they're trying to do some kind of exploitation or malware attempt? We're trying to understand where are they at in their progression in the hack against this particular application, and therefore either due to a multitude of indicators or just due to the severity of what they're trying to accomplish, that's really what drives the blocking from our perspective. What that allows us to do then is, if what they're doing is really early in the attack state, they're not doing something that's super high risk, it allows us not to block them immediately, reducing the false positive risk, but also allowing us to gather more intelligence about how they go about approaching hacking applications. And that helps us then build kind of a profile for what they're doing and how to identify them later if they're coming from another IP.
Okay. Why focus on what the attacker is doing instead of what the attack is?
I think it's really twofold. I mean, again, you can focus on what the attack is if the attack's already been defined. And that really kind of gets, to me, that's akin to static signatures or static rules. It takes somebody discovering that an attack has already happened and discovering how all of the steps were done and then writing a static rule. The reality is the attackers are much more comprehensive than that. And it kind of goes back to our opinion on maybe blacklisting. The really advanced attack guys that are out there, they know they're on the blacklist. They're not going to use that IP. They may know that it's been figured out one way that they attack an application, so they're going to use another alternative method. So we really try to focus on what are the behaviors that we're seeing or abnormalities that we're seeing, but how can we classify that particular behavior, and then how can we piece all of these puzzle pieces together to identify that we think this is an attack. That helps us, obviously, as they continue to morph their attack structures, and it certainly helps us with things that have not yet been identified. I'll stop short of 0 day, but certainly say a lot of what we're seeing out there is stuff that may not pop up on somebody's vulnerability assessment for several days, just simply because we picked up on all the other pieces that they were doing before they got to the exploit.
Excellent. Yeah, let me just add a point. I think there's a parallel, or I believe there's a parallel here. As in our research practice, we're looking across several cybersecurity technologies, and the parallel is if one thinks about how endpoint protection has evolved. Generally speaking, it was the base was antivirus, signatures. And rules and stuff of that nature that were more or less static, and building incredibly large libraries of what the bad behaviors or known bad behaviors are. What's transpired is it has been augmented with endpoint detection and response, which is akin to what Bret, you're talking about in ThreadX is similar but not the same, but again an element of how does the technology, how is it leveraged to identify abnormalities? And I think the key point that's challenging for all these type of solutions, and you touched on it as well, Bret, is it's not just within a single silo of an abnormal behavior, it's within a broader context. That's what's, has to be done as well, not just a behavior, but multiple behaviors, so you can triangulate across all of that, material to make more, say, accurate decisions as to what is truthfully occurring.
Okay.
Yeah, I agree.
All right. Aside from the usual pen test, what's the best way to see vulnerabilities in my apps?
Well, I mean, there's obviously a range of options that are out there, from vulnerability scanning to penetration testing to code reviews, which are all kind of variations of a theme of how you can go about assessing the applications. The shameless plug, I guess, from the ThreadX perspective is we encourage the use of all of those techniques, but also what we see is we like to have the metrics on what are the actual outside world, what are they focused on. And so as I mentioned, part of the product that we have has a component that is called the top targets. It identifies the applications, but more importantly, it identifies the URIs within the applications that are being targeted, and it identifies the techniques that are being used to target those particular components. And that's, again, that's very useful. It helps us when we are working with our customers to be able to say, they're targeting this because you're 3 versions behind maybe patching your WordPress. Or they're targeting this because you released code last night and you left indexing turned on. You had a code change that occurred last week and it looks like you're passing clear text. So there's always variations that are out there, and we, like I said, we encourage the use of all of the above when it comes to evaluating your code and trying to make sure that your development teams are releasing the highest quality of code. We also like, though, then laying on top of that another layer, which is how do you actually focus on what the bad guys are actually targeting.
Yeah, and if I might add, to a point you made earlier, Bret, in your presentation about there's an increasing number of developer tools out there. There's also an increasing number of use of third-party libraries. All those things are valuable, but they add to the, velocity that applications are being changed. And with that velocity, a greater amount of greater potential of vulnerabilities. Again, not just in the introduction of, let's say, vulnerable software, but vulnerable logic. And it's how do you stay on top of these things? And while I agree with your point, Bret, all these other tools are valuable. They narrow the exposure surface if they're used properly and comprehensively. But when they're not used properly or it's not comprehensive, what is your alternative? And that's what I think organizations need to be consider.
Agreed.
Okay. So we have a small team, and how is this easier to manage than other web application firewalls?
Well, I guess my answer would be there's a couple of things that we feel like we're trying to really help organizations that, it could be a small team or it could be a large team. It doesn't really matter. There's always a shortage of talent, it seems like. And there's a shortage of folks who have the cycles to be constantly perusing the results that are coming out of the security products that they're using, and then trying to figure out how to tune the actual solutions that are active in the actual defense or blocking side of the equation. So, a key of what we're trying to do with ThreadX is there aren't static signatures to manage. Again, when we encourage everyone to, I'd love to have you all do a proof of concept with us. We do a free, POC, and, from the time that we deploy the application to, 24 hours later or less, you're seeing the real results in terms of all of the malicious activity that's hitting your website, and you've done that without actually managing a lot of rules. The implementation is a very simple implementation. Typically for a POC, we would encourage the, routing your traffic through our network. There's virtually no latency, and the implementation is as simple as a DNS redirect. So you're changing, basically just pointing your applications to flow through our network, and then you're seeing the results almost instantaneously. And then at the end of a POC, we're always going to sit down with the customers, walk through not just the application, but we're going to walk through what we saw, and we're going to really highlight a couple of key areas. One will be, what were the most sophisticated attacks that we saw during that period of time? And how do we break that down in terms of, overall risk? Should you be concerned because you've got a high number of attacks, or should you be concerned because of the sophistication level that we're seeing? And again, those aren't mutually inclusive or exclusive. And then on top of that, we walk through, these were the vulnerabilities that were discovered, because these are the things that the outside world saw and that are being targeted that you need to be able to address. And those are really the, the outside influences plus kind of how you're managing and maintaining your applications. That's what's really driving the overall risk. But I'll bring it back to the question. I mean, we support the small teams because we're giving them a tool set, we're giving them visibility to not just their applications, but information out of our managed services group for what all of our customers are doing and what we're seeing across that customer base and how all of our customers are responding to those various different threats. That's something that's very hard to do when you're a small team. You only have a perspective of what you're seeing for your own organization, for your own applications. We're able to kind of help address some of those concerns.
Okay, well, that's going to have to be it for this session. Just want to let you guys know that this presentation slide deck will be available for download. And just a reminder that today's session will also be available for download tomorrow at scmagazine.com under events. Thank you, Michael and Bret, for being with us today, and thanks to all of you for tuning in.